Just also waiting for, okay, so the visual cue to show up. So for this panel, we are actually missing a few folks. So if anybody wants to volunteer to join us, raise your hand. No, I'm serious. Okay, so I would actually like to invite two of the panelists right now, and one panelist will be joining us just a little bit later. So I would like to invite Babak and Jeff both on stage for our discussion right now.
Yeah.
Okay. So before we do introductions for the panelists, maybe we can set a little bit of context over here. We're basically concentrating on panel discussion basically about how do we use some of these sustainability metrics for better data center efficiency. And I know there are a number of metrics experts that are right now sitting in the audience also. So the panel will be an open discussion. Feel free to sort of raise your hand or come to the mic, and we'll sort of try to put the question in the middle. To set this context, a lot of companies, a lot of the industry is right now having a net zero goal for carbon. And part of that is the scope 2, which is the power, which is basically the carbon out of the utilization of power. Around this utilization of power, there are a number of metrics that have been established in the industry. And there comes in our third panelist, Miranda.
Oh, want me to sit there? Okay.
Yeah. So there are a number of power-related metrics that are already established in the industry. Some of these metrics are being improved sort of results in another metric being compromised. So the industry as a whole is trying to grasp with which metrics we should be looking at, which are the more important ones, which are less important ones. And these folks have been closely working with that entire aspect. Listed here are some of the existing metrics. Of course, PUE, which is everybody's favorite child. Then CUE, which is carbon efficiency. WE, that is basically concentrating on water. And also GWP, global warming potential. A little bit less known in the discussions. But all of these metrics right now exist. And there is another metrics that OCP is proposing, which we saw in just the last session. That's IUE. Infrastructure efficiency, infrastructure utilization efficiency. So with all of these metrics existing, where are we currently and how can we sort of bring the industry together? I would, with that background, like to invite our panelists to introduce themselves and also tell us a little bit about what they are involved in so that we can shoot tough questions at them.
Thanks. I guess I'm starting, and appreciate your patience on my tardiness. I did not pay attention to my schedule that I was on stage in 3 back-to-back, so I just ran from the Innovation Summit downstairs back up here to talk to you guys. But if I didn't see you 2 sessions ago, my name is Miranda Gardner. I'm the executive director of the iMasons Climate Accord. We are a nonprofit focused with our member companies, our members are companies, on decarbonization and digital infrastructure. And to the metrics that Shruti shared with us, part of our goal is to ensure the accuracy of the data when we're tracking our carbon. No matter which metric you're using, we're digging into the fact that sometimes those numbers they're not always the same across the board. And it's really critical to be very transparent with us and very collaborative in the process. We have some additional sessions going on in terms of our partnership work that we're doing with OCP to really enhance that kind of understanding of where these criteria are, where we're seeing these criteria really swing in wide variables, how we establish a baseline for them when it comes to our key focus areas, equipment, power, and materials, and also to lean into any of the other work that is being done when these metrics get updated, how we can be best of service in terms of the experts that we've got in-house to ensure that the data centers are being accurately represented and kind of coming through on the ones that you shared previously. So that's kind of in short, and I'll let my other panelists talk about their work.
Yeah, and except for you, everyone I think was here. So just in the last session. So yeah, again, my name is Jeff Otter. I'm with Hewlett Packard Enterprise, and I also, from OCP's perspective, I participate here in several of the work streams of sustainability. But I also co-lead the hardware management sub-project in OCP. So I have a vested interest in the metrics and the way that this impacts all of the product pieces. And in my other hat, I also am the co-chair of the Redfish Forum and the standards group, the DMTF standards organization that defines the Redfish specification and protocol for systems management. So trying to enable all this stuff.
I think I have this.
You got a mic.
Yeah, thanks.
He's got a fancy one.
Yeah, I got the embedded one. So Babak Falsafi, the founding president of the Swiss Data Center Efficiency Association. And what we've done is that we've launched a platform online where people can go, and they have 3 calculators. One is a DC energy flow, where they can get their PUE, but we also have an integrated index, so we bring in waste heat recycling and also on-premise renewables. We have an IT calculator, which is novel because there are not a lot of IT KPIs, and we're also part of this work stream trying to evolve, create these IP KPIs, and we also have an emissions calculator for DC operation. What we find in the market today is, A, the KPIs are super important, but also the customers have no way of measuring them. So even if you come up with the right KPI, so we're trying to help our customers with that. My other hat is that I'm a professor of computer science at EPFL in Switzerland. EPFL is the Swiss Federal Institute of Technology in Lausanne. And before that, I was a professor of computer engineering at Carnegie Mellon. I've done all my life server design from enterprise all the way to cloud, and now we're doing post-more. So.
Thank you. Welcome, panelists. And just before proceeding, I would like to remind if anybody wants to pose their side of questions regarding this topic, feel free to raise your hand, and we can totally have this like an open discussion. To start off, I would like to pose like a historical question to all our panelists. So up until now, which data center metrics do we think have done really well in encouraging data center efficiencies? And right now, what are the shortcomings or limitations we are seeing in them?
We're not kidding about the hard questions.
I was told there would be no maths.
Yeah, I know. She threw us for a curveball.
Might be told wrong. We might ask you to get a whiteboard and.
Fantastic. Arguably for me, it's PUE. I come from a commercial background. I have built rating systems, used to work for U.S. Green Building Council. I mean, this is sort of the metric that set off, in my opinion, the rest of them and has really driven the efficiency further. Is it perfect? No, but I don't think anything is perfect out there right now. And to, again, have a kind of common language or understanding of what PUE means has driven data center market, but really the entire built industry when we're looking at it as a whole. So that's my short answer.
I think my short answer is just the availability of power measurements, and it's essentially an accident that all the IT gear even report their power consumption in terms of programmatically. You know, I can obviously go put an ammeter on or a watt meter and look at the stuff, but getting that data live, it was started probably 25 years ago as the power curves became more significant when we started really putting things into racks. And here in California, I think everyone remembers if you're old enough, the rolling blackouts that were right at the peak of the .com era. So suddenly people were very, very interested in how much power they were consuming, not because of efficiency, but because they had 2 issues. Number one was they had to get standby power sized appropriately, so they needed to know what they were consuming, and also in terms of they were stacking racks of stuff so quickly that you would go trip breakers because you go start putting in more gear, and you would overload it, and meanwhile the rack next to it is sitting at idle. You'd stranded 5 kilowatts of power, and now 5 kilowatts is like in the round off of these racks talking about 140 kilowatts. But anyway, So that's why the power is being reported by all these devices. It wasn't for energy savings. It wasn't for efficiency. it was for another purpose, but luckily we've got that data, and so now we're using that to look at all these efficiency pieces and then add on top of it. And as I said in the previous talk, trying to move folks not just to look at power measurements, but also energy measurements, because that's a much more accurate way to look at your consumption, because I don't have to sit here and sample every couple seconds on these very, very dynamic power loads. Instead, I can just look at how much have I paid for. It's just like your electric meter at home. I can watch the little dial spin, but what you really care about at the end of the day or the end of the month when the check, when the bill comes, is how much did I consume over that unit time. So anyway, that's my long answer.
So obviously PUE has been key, and what's interesting about PUE is that it's so well established, and most DC customers we talk to, they have the right things in place to be able to measure it. What is lacking in industry right now is methodologies to properly measure it. So everybody reports PUE, but I don't think we have a consistent way of reporting it, and so there is a difference between theoretical PUE or the PUE you designed for versus the actual PUE you measure over 12 months. With climate change, things are moving too. So that's interesting. The other thing is that evolving PUE so that it does an end-to-end energy flow. So if you have waste heat recycling, or if you have on-premise renewables, you can bring that into your index. And again, that's something that we can do, which is good. Now, moving forward, I've written a lot of blogs about goodbye PUE. Hello, full stack efficiency. I think the key challenge is in IT, and we have, so the data center market is half of it is hyperscalers, the other half is private data centers and co-locators, and we're seeing even leading co-locators, Digital Realty, they just got measured and properly certified their data center in Zurich, and they reached less than 1.2, which for co-locators, that's really good. 80% of your electricity is now going into your IT. So.
I guess one last thing, though, too, is as much as those of us in the room understand these measurements, there's still a whole host of people that don't. And I've heard this, clients or customers will go to their colo and be like, I need to have a 0.9 PUE. And it's like, you have no idea what this means. So anyone who's here listening to this session, too, if you are familiar with this, be sure to educate people on it, because none of these metrics or ways of calculating can scale in the proper ways unless those of us who understand them message properly and kind of share the information and why any one of us or colos or hypers are looking at this kind of information. That is also kind of a key critical point of any of it. Sure, familiarized terms for us, not necessarily outside these walls.
And with the mention of PUE, there is a particular white paper work that some of you folks are involved in. Can you give us a one-liner of like what's the main gist that white paper on PUE is trying to do right now?
So I'm on the IUE work stream,
I think it's
so I don't know if Jeff.
So yeah, I didn't write the white paper, but yeah, the point of that, if I remember which one is which here. So there's kind of, because there's two white papers in my head. There's the new one defining the new ITUE. And so that's trying to explain and having to come up with the right terminology. Like it's just the gentleman asked the question earlier was, well, what do you mean by IT? So I'm like, well, I'm trying to make it a nice abstracted. It's the movement or the processing or the storage of data, and that's IT power. Anything that's not involved with that, meaning spinning the fans, running converting DC to DC, or blinking lights, none of that stuff is IT. So that's that. So that's the one white paper. The other one is trying to just explain PUE and move from the static, the kind of the predefined, as you say, the static PUE values that were, at the build time of the data center, to how do we move that into dynamic and then building the measurements so that you can get something that actually reflects the real world after after day one, because obviously things change, equipment gets swapped out. So moving to that thing is the other focus of that. I hope.
And there was a mention about, there is PUE defined, but then when PUE is reported, there are sort of, I'll call it loopholes, or essentially, places where not the entire information gets conveyed or does not accurately get conveyed. So let's talk about the reporting of these metrics. Like, how do you see the current state of these metrics being reported? And do we think that there needs to be more regulation around it? Or how should we actually bring about the reporting of these metrics be better and usable?
I guess I'm from Europe, so I should comment on this. Okay, we're from
Regulation
Switzerland.
Best to comment.
In Switzerland, we don't have regulation. So Switzerland is a libertarian country, and we only have stakeholders who opt in. So all of our customers are basically opting in. There's no regulation. Germany is probably the most advanced when it comes to regulation. And in fact, there are several of them that are coming up that are sort of, there are also discussion that we have in the work streams as some of these regulations coming up. And I think it's super important to have a proper standard for measurement and reporting, because otherwise there will be a lot of confusion in the market as to what's exactly being done. In our case, we have a reporting process, which is a 12-month reporting process with SDEA, and that is consistent with both ISO and EN directives that are out there for proper measurement and reporting. But yeah. That's a very good point. So I'll let you guys comment on that.
I guess from the power and energy measurement side of the list of things, I don't think there will be a need for regulation, because your energy consumption, for any commercial enterprise is a cost, and so they will, by the very nature, seek to the lowest cost of those. So if we can show more efficient energy usage, of products, they will naturally migrate to the ones that are more efficient, because it equates it directly to the bottom line. Now, the other metrics for carbon, for water usage, I forget the other one. That's the other big bucket.
Heat recycling.
Heat recycling.
On pros.
I think those, maybe there will be some need for regulation just from make sure that, again, that we report that, and so you're getting equal comparisons. And I hate to throw the greenwashing word out there, but that can be a big issue that kind of undermines these efforts.
I would counter that, not because
So interesting.
I don't agree. I hope that we don't need regulation.
Hope not.
I hope so. But to look historically at how we've changed the conversation around sustainability, regulatory has always been the piece that kind of kicks it back off. Again, you referenced going back and working at U.S. Green Building Council, developing LEED. LEED was kind of this nice to have. It was still only 10% of the buildings. All of a sudden, the U.S. federal government picks it up, and now it's state requirements. You have to meet LEED Silver. Now to get tax benefits, you have to do this. Now this isn't part of the ethos. It's a conversation. I knew teenagers who were like, oh, you work there? Like, what do we do for a LEED plaque? That, to me, helps drive a much broader impact that we want to have and what we want to see. And back to kind of the work that we do at the Climate Accord, our goal is to have those kinds of agreements, especially from our hyperscalers and our colos, because they make up not only the bulk of membership, but really the bulk of the kind of purchasing power and the drivers that do this. If they do it, now their supply chain pays attention, their delivery partners pays attention, their customers, et cetera, right? It kind of goes down the line. Ultimately, the goal is, as close as we can get to ensuring the accuracy of these calculations, the better off we'll be when it comes to either regulatory or reporting, that we're not asking again and again and again and kind of wasting our time doing a checkbox exercise, but rather being able to now innovate off of these solutions. Okay, we've become this efficient. What do we do on the next step? Now those brains really can be applied to finding solutions and impact further down the line.
Just want to quickly comment also on what Jeff said, but from a bit of a different angle. So the DC operators who work with the collocators, they have a pretty good idea of where their electricity is going, and it's in their interest to improve that, which is good. The IT customers are completely lost. We have IT customers who are operating entire racks at less than 10% utilization. And so if you use our platform to come up with an index that says this is your efficiency, by the way, our index for IT is on the same scale as PUE, is similar to IUE, then you can potentially deliver the same exact output with half the number of servers. So not only you get better efficiency out of your operation, you also reduce your embodied carbon. And I think that's where we need to move. But whether that is going to come with regulation or not, I don't know. But I can tell you the IT market right now is not very good.
Okay, I almost feel like doing a poll in the audience, because there are contradictory, opinions here. So who feels like we need regulation for the metrics and who feels we do not? but I'm also told I have like a minute or so to go. So I would actually like to leave a minute if somebody has a question to bring up to our panelists, or otherwise I will have a last question for them. Yes. Do you want to use the mic?
This is coming from somebody who's largely a scope 3 kind of person, so on the embedded carbon side of things. Saying that because this might be a silly question, but where do you see the importance or the balance in terms of workload efficiency versus hardware efficiency? How do you segregate the two when measuring them, and where do you think is really the bulk of this? Like fleet management, load management, geographic shifting, time shifting, versus the hardware itself. To Jeff's earlier presentation, the DC conversion not being as efficient as it could be. Just wanted to hear your thoughts on that.
Yeah, so I'll take that.
Do you want to repeat the question?
I'll repeat the question.
Yeah.
Because I don't think Mike picked him up. But the question was in terms of workload efficiency versus just raw hardware efficiency, and then as you move things around and all the other measurements, how does that all affect it? I'm trying to paraphrase that. So the first thing is a lot of this is a black art right now, and so the first thing is it can't explain it if I can't measure it. So that's why the metrics in getting this stuff out, and from a standards guy, I'm trying to get everything in the same format from all the different gear, because nobody, it's just numbers. There's no value add in I measured it in furlongs per fortnight or slug feet per second. Just give me the data so I can start making heads or tails of this stuff, and then I can make comparisons. So hardware efficiency it will be workload dependent. We have sold a lot of gear over the years by showing that, hey, I can take the same workload and run it 10 times more efficient by upgrading a 5-year-old server. Those kinds of things have been and I need fewer things, but of course IT just continues to consume all available product, right? So, but it's, to me, the first step is we got to be able to measure the stuff and be able to piece out where that consumption is going. Is that memory? Is that processors at GPU? So that I can characterize those workloads, and then we can figure out how to move things around. Some folks will think that we'll be doing this like every 5 seconds. You'll be moving a workload from point A to no. Like the IT guys are going to just they're going to have to get out their airsick bags, right? That's just not going to happen. But it might be on a daily basis. It might be I may follow the sun and follow the renewables around the world as depending on the latencies, et cetera. I can't do all the fun stuff until we can get the basics. So that's my focus. Is we've got to get the basics, be able to measure the stuff, and have consistency among the measurement, and have it solved accurately. So then we can start to compare, and then we can start taking action on that.
I think also just understanding where there's going to be trade-offs. No matter where you're most efficient, likely something else is going to have to balance out in that load. And depending, to your point of like geographic region, take a look at, is this an area where solar can be more of my renewable portfolio? Okay, perhaps we're going to balance that out with understanding now I got to pay and buy more solar panels, which probably increases my scope 3 impacts, on and on. And so again, looking at it holistically is really the approach, but I agree. The basics are critical for us to make that decision. And it's really about informed decision making at some point.
So I'll have to agree also with Jeff and Miranda. So hardware efficiency is my academic hat, because that's what we do in the lab. Workload efficiency is what we do in SDA. We're now in what's called the post-Moore era of computing, because Moore's law is sort of coming to an end. That means that silicon used to get denser, it's not getting denser anymore. And we're going to have all sorts of interesting hardware. Fortunately, this hardware will be more efficient because it's going to be specialized. But then the question is, A, as Jeff said, can we properly measure and figure out whether we're using it correctly? And then B, how well would the workloads then find a way to use it? And so a lot of that goes back to, yes, we need transparency, and we also need to figure out, are we consolidating the workloads properly? What we see in the market today, even with CPUs, not accelerators, IT people have difficulty properly consolidating workloads in a rack of servers.
Thank you. I know we are over time. We do have one more question. If we are not pushing out another session, could we let the last question go. It is
after,
lunchtime, so just for folks who are hungry,
good one then.
feel free. But I would
Yeah,
like to allow.
I work a bit in power electronics, and I'm seeing that with gallium nitride devices and silicon carbide, the controllers are a lot more complex, and people are putting in RISC-V processors and things. So you can talk to those things and find out what they're doing more easily. Are you pushing any standards for people to give you metrics for how the power management's working in the servers?
So did the question come through? So the question is about is the down at the component level. There's lots of more data being can be produced from the power devices so that this all can be reported. Are we placing requirements on on the components and on the vendors to do that? I'm going to do it indirectly because we try to do this like at the kind of the black box level of as long as you can report the values that we care about, the energy and the power. I don't care how you do it. Now, when I say that, well, you need to, each of your power devices needs to report that, well, then it effectively puts those requirements on them. So we're not driving the standards of the how do you make that happen. That I think there's a lot of other groups that will take care of that.
What would be the incentive for people to add that?
The incentive for adding that stuff, because it costs money, right? So the incentive is, back to my previous talk on the profile is, well, when we have the ITUE things defined and say, look, in order to meet the profile, you have to be able to show the efficiencies, the input and the output power from all of your power devices. If I say that that's your check mark. If you can't meet that check mark, then you don't meet the profile. You don't get your sticker of OCP sustainability, thumbs up. That's going to be our financial incentive. Is so because please everyone, we want to do that, and then we want you to all put that on their RFQs that things have to pass the profile and meet the requirements of OCP sustainability. Put that in your RFQ so you can exclude all the vendors that don't meet that stuff. So this is how we affect change.
Can I just add that it's not enough to have those various instruments in so that when you ship a product, you have a sticker that says this product is really good. It's also important to measure all these things in deployed settings, right? And there is another challenge there, is that, how does the operator really figure out how to do this, right?
Awesome. Thank you so much for giving extra of your time. And thank you so much, folks. Feel free to grab lunch. We will meet here again at 12:30.
1:30?
Oh, sorry.
12:30, yes.
12:30.
12:30 to continue the rest of our sessions. The afternoon has a number of interesting sessions, and a lot of which we want to, open for discussion. So we want folks to be able to question. So see you folks after lunch.
Thank you.